Okay, ladies and gentlemen, today we are working on solving compound inequalities. The inequalities you have seen so far are simple, and when two simple inequalities are combined into one statement by the words and or, the result is called a compound inequality. So, let's take a look at one example. The free chlorine level in a pool should be between 1 and 3 parts per million inclusive. Write a compound inequality to show that the levels are within this range. So this is telling us that the chlorine has to be greater than or equal to 1.0, but the chlorine also has to be less than or equal to 3.0. So this is called an inclusive or compound inequality. So because it can be greater than or equal to, as indicated right here by 1, and less than or equal to 3, we are going to have two closed circles on our number line. One being at 3 and one being at 1. So we have this, it looks like that, so we just plot like usual, 3, 2, 1, 0, -1. We can also indicate more by going up this way. And then our line is actually going to be a line that looks like this, and it's only going to include that one area. So I can make that red or something just so you can see that I'm only including that little area between 1 and 3. Okay. Let's look at another example. We're going to solve these compound inequalities and graph the solutions. So here we have 2a, -9 is less than x minus 10, which is less than -5. So, how are we going to do that? The first thing we need to do is look at this like it's two inequalities. So we have -9 is less than x minus 10, and we also have x minus 10 is less than -5. So you see what I did is I took out that x minus 10. So what I'm going to do is I'm going to add 10 to each side here, which is going to give me 1 is less than x. And I'm going to add 10 over here and solve this inequality, which is going to give me x is less than 5. So if I put them together, okay, I can now rejoin them, and I'm going to have 1 is less than x, which is less than 5. These are not open circles, they're closed circles, so let's set up our number line. So we're going to go, let's see, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're going to do open circles on 1, because it can't be equal to that, open circles on 5, okay, and x has to be greater than 1, but it has to be less than 5. So then we take our line, we put it in between, and just so you guys can see it, I'll change the color, and oops, I'm going to make that a little smaller. And it looks like that, okay? Okay, let's try 2b. -4 is less than or equal to 3n plus 5, and 3n plus 5 is less than 11. -5, 3n is less than 6, and -5, 5, we're going to have -9 is less than or equal to 3n. Isolate the variable. N is less than 2. Isolate the variable. We're not multiplying or dividing by a negative, so we're good to go. So we have -3 is less than or equal to n. So now we can put them back together. -3 is less than or equal to n, which is less than 2. So we're going to set up our number line again, -4, -3, -2, -1, 0, 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay, so now this time we're going to have a closed circle on, or open circle and a closed circle. I'm going to grab my circle over here. I can't grab it. Okay, I'm going to have a closed circle on the -3. I'm going to have an open circle on the 2, okay, because it has to be, n has to be less than 2. And then I can still grab my line, and it looks like between those two values, just like so, okay? And that's what that would look like. So n is greater than or equal to -3, and n is less than 2. So those two examples were examples of and inequalities. The next two that we're going to look at are or. So notice that the joining word is or here. So the first equation we're going to look at is 2 plus r is less than 12, okay? And or r plus 5 is greater than 19. So I'm going to subtract 2, r is less than 10. And over here, I'm going to subtract 5, and I'm going to get r, which is looks like an n, r is greater than 14. So I'm going to set up my inequality over here. So I'm just going to go 8, 9, 10, 11, 12, 13, 14, 15, 16. In the first instance, I have r is less than 10. So again, it's a open circle on 10. And I'm going to be going in the direction because this way r has to be less than 10. In this equation over here, r has to be greater than 14. Still, as indicated by the sign, an open circle. So I'm going to grab an open circle. I'm going to put it on 14, and I'm going to say r has to be greater than that, so r goes in this direction. So I've got a set of or inequalities going to the right of 14 and the left of 10. Okay, how about the next one? So the next one says 7x is greater than or equal to 21, or 2x is less than -2. So I'm going to solve one-step inequality, divide by 7. X is greater than or equal to 3. Over here, divide by 2, divide by 2. X is less than -1. So I'm going to graph the first one. As indicated by my sign, I have a closed circle. Oops, I forgot to label my graph first. Let me do that. -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. That should be enough. I'm going to put closed circle on my +3. X has to be greater than or equal to that, so I'm going to send my arrow in that direction. And over here, x is less than -1, so I have an open circle on -1. X is less than that, and that solves my inequalities for that question. All right. Now we have writing the compound inequality shown by the graph. So in the first instance, we have an and, okay? So we have a value of x, which has to be greater than or equal to, oh no, not equal to, just greater than, it's an open circle, 9, or -9. And x has to be less than -2. So that's an and. So that's how you know the x value has to be between -9 and -2. In 4b, we have a closed circle, and x can be less than or equal to -3. That solves for all those values. And it's a closed circle, so that's how I came up with that sign. And, or x has to be greater than or equal to, closed circle again, 2. And that's how you would get those two inequalities for compound inequalities. Okay, so work for today. Page 138 to 140, questions 16 to 44 even. Good luck.